Hello everyone, welcome to my channel Physics Tricks. So let's continue with our current electricity DPP, and in this we have first question, and that question says determine the value of current in 3 ohm resistance and potential difference between A and B in the given circuit diagram. And this is the circuit diagram given. So as you can see over here, and we want what is the potential difference between A and B. Okay, so to solve this type of problems, what you have to consider is always consider any one point potential as zero potential. Okay, so that is any one point will be the ground, right? So over here I'll consider this point as ground. Okay, you can consider any point as ground potential, but I am considering over here that is the ground. So ground indicates it must be 0 volt. Okay, so as this is 0 volt, this must be 0 volt, this B must be 0 volt, this point must be 0 volt. Why? Because this is a short circuit line, isn't it? Short circuit line. Okay, so this is 0, indicate this must be 0 volt. If this is 0, what is this? Potential difference across this must be 2 volt. So this must be 2 volt, this must be 5 volt, and as you can see across this 3 ohm we have what is called as the potential difference of 5 minus 2, and that is 3 volt right now. So potential difference of 3 volt we have. Okay, now and across this 2 ohm we have potential difference of 2 volt. This is plus, this is minus. So current will flow from higher potential to the lower potential. So I in 2 ohm is 2 by 2, that is 1 ampere, and I in this 3 ohm is 3 by 3, that is 1 ampere. So that indicates the current in the 2 volt branch is 0 ampere, and this whole current will pass through this branch. Okay, now so over here what is the answer? Answer for this question is the potential difference between A and B is 2 volt, and the current flowing through the 3 ohm resistance is 1 ampere. So it is very simple if you go with the basics. Okay, now so current is 1 ampere and the voltage is 2 volt. Now some of you will say, why sir you considered only the ground at this point, that is in the at point B? Why can't we consider at any other point? So you can consider at any point. That is not at all a issue. You can consider the ground at any point. So see here, I'll consider the ground at this point. What will happen? Nothing will happen. This is 0 volt then. This is 0 volt then. This is 0 volt then. What is the potential at this point? Tell me, potential difference across this must be 2 volt. So this must be minus 2 volt. Understood? This must be minus 2 volt. Okay, if this is minus 2 volt, this must be minus 2 volt. If this is minus 2 volt, what is the potential at this point? This must be 3 volt. 3 minus of minus 2 will become 5 volt. 3 minus of minus 2 will become 5 volt. So this point potential is minus 2 volt, indicate this point potential also minus 2 volt. This is 3 volt, this is minus 2 volt, right? So what is the potential difference across this? The current will flow from higher potential to the lower potential, and across this 3 volt potential difference, that means current in this is 1 ampere. Current in this is higher potential, lower potential is minus 2. Current in this, the potential difference is 2 volts, indicates current in this 1 ampere, and same, everything will be same, but the potential at point will change, but the potential difference will never change across the element. So that is what we have over here. So I hope this is clear to you all. Now the next problem, the given Wheatstone bridge is showing no deflection in the galvanometer joint between the point B and D. So we have to calculate value of R. If the galvanometer is not showing any deflection, that indicates what? This divided by this must be equal to combination of this divided by this. So it must be for balanced Wheatstone bridge, we have what is called as R1 divided by R2 must be equal to R3 divided by R4. So what is R1 over here? 100. What is R2? 200. Must be equal to parallel combination of R and 100 divided by 40. So if you just solve this, you will get 1 by 2 is equal to R into 100 divided by 100 plus R into 40. So we have what is called as this 0 get cancelled. This is R divided by 100 plus R is equal to 2. So R is equal to 200 plus 2R. So 2R minus R, right, this minus 2R, it will become is equal to 200. Just a minute, I think we did somewhere mistake. Yeah, so see here, this is 2, this is 10. 10R is equal to this one, so this is 10R. So it is 10R minus 2R, so it is 8R is equal to 200. R is equal to what? 8 2s are 16, 4 8 5s are 25 ohm. So I hope this is clear. I hope this is clear. Right, this is the 25 ohm. That means you have to just see the condition over here. 100 divided by 200 is equal to parallel combination of this divided by 40. So I hope this is clear. Chalo, the next problem. Find the equivalent resistance between the point A and B of infinite ladder shown in the figure. Okay, so this is the infinite ladder given. That indicates this structure will go till infinity. So this structure will go till infinity, and this is R, this is R, this is R, this is R, all are R. Now see, if I remove one from infinity, what will happen to the infinity? Nothing will happen, right? So if I just remove this from infinity, nothing will happen to the infinity. So, and if I see the equivalent resistance between these 2 points, it will still be the same, right? So we have, this is R, this is R, and this one is the R equivalent, right? R equivalent. Okay, so if you just take the parallel combination of these two, you will get R equivalent into R divided by R plus R equivalent, plus R must be equal to what? R equivalent. So if you just solve this now, R into R equivalent plus R squared plus R into R equivalent is equal to R equivalent plus R equivalent squared. So now if you just solve this, you will get this is R equivalent get cancelled. So it is R equivalent squared minus R into R equivalent minus R squared is equal to 0. So this is the quadratic equation in R equivalent. For roots, you have to apply the R equivalent 1 comma R equivalent 2 is equal to, for roots minus B, that is R plus or minus square root of B squared, that is R squared, minus 4AC, that is 4 into minus R squared, divided by twice A, so 2. You will get R plus or minus root of 5R squared divided by 2. So which is equal to R in bracket 1 plus or minus root 5 divided by 2. Here resistance negative not possible, that's why R equivalent we have is 1 plus root 5 divided by 2 into R. So I hope this is clear. I hope this is clear. It will be very simple if you go with the basics. Okay. So the next question we have, fourth question, a battery of EMF 10 volt is connected to a resistance as shown in the figure. The potential difference between A and B will be, that is VB minus VA we want. Okay. So what is the potential at this point and that potential at this point? So if you know the potential at this and this, take the potential difference, you will get the answer. Okay. So firstly, what we'll do is we'll calculate the total current in the circuit. So what is the total current? Total current in the circuit is the voltage in the circuit 10 divided by R equivalent. Now what is R equivalent over here? It is 3 plus 1 4, 3 plus 1 4, so it is 2, so which is equal to 5 ampere. So this I is equal to 5 ampere. This 5 ampere will divide into two parts. It will be 2.5 ampere, 2.5 ampere. Why? Tell me why? Because because this resistance and this resistance both are same, right? 3 plus 1 4, 3 plus 1 4. Okay, so if you consider potential at this point as 0 volt, what is the potential at this point? It is 10 volt, है so this will be plus minus 2.5 volt, right? This is 2.5 volt and this is, we have plus minus 2.5 into 3, it will be 7.5 volt. 7.5 volt. So if you consider the potential at this point as 7.5 volt, it will be same. 10 minus 2.5 is 7.5 volt, and at this point it is plus minus 2.5 volt. So it is, and this is plus minus 7.5 volt. So 10 minus 7.5 is 2.5 volt. So VB minus VA is equal to, we have 2.5 minus 7.5, which is equal to minus 5 volt. Minus 5 volt. So I hope this is clear. I hope this is clear. So the next problem we have in this fifth question, as you can see in the circuit shown in the figure, if the current in the 5 ohm resistor is 14 ampere, the constant voltage V of the cell is, so V is equal to what? So 5 ohm resistor is given, that is 14 ampere. So what is the voltage across it? 14 into 5, that is the voltage across it. So 5 4s are 5 1s are, it is 70 volt, isn't it? 70 volt. So what is the current through this? Because it is 70 volt according to Kirchhoff's voltage law. This is also 70 volt. This is 7 ampere. This is 7 ampere. So 7 7 14 14 28 over here. So 28 into 2 is 56 volt. So the total voltage, therefore we have is 56 plus 70 is how much? It is 612. So it is 126 volts. So I hope this is clear. It is the option B we have. Now the next question, the potential difference between points A and B in the section of circuit shown is between point A and B we want. Okay, so this is 3 ampere, this is plus, this is minus 6 volt, this is plus, this is minus 3 volt, this is plus, this is minus, because this is 1 ampere, this is 3 ampere, this is 4, that is 4 volt, this is minus, this is plus 2 volt, this will be 2 ampere this side, 4 ampere incoming, so 2 ampere, so plus minus 2 volt. So from A go towards B, so it will be VA minus 6 minus 3 minus 4 plus 2 minus 2 is equal to VB. So VA minus VB is equal to, this is 9, 13, 2 get cancelled, 13 volts. So the potential difference we have is 13 volts. Now here what you need to remember is, for a resistor, if current flows from A towards B, it is the A terminal positive, B terminal negative. But for a resistor, if current flows from B towards A, B is positive and A is negative. That you need to remember. And for a battery, the bigger terminal is always at higher potential and the smaller terminal is always at lower potential. So this you need to remember. Sure. The next question, in the seventh question, we have which of the following is true? Okay. Resistance is the opposition to the flow of current. Yes, true it is. Resistance is what? Opposition to the flow of current, isn't it? True. Effective resistance in the circuit is 2 ohm. So we'll calculate effective resistance across this. So this is 1, that means 2. So this 2 is in parallel with this 2. We'll get 1. So this total we have is 1. 1, 2, 3. 3 parallel with 6, 2. 2, 2, 4. So this is wrong. Right, this is wrong. The direction of current is assumed to be opposite to the direction of motion of free electron. That is correct. This A is correct, C is correct. The effective resistance in the circuit is 4 ohm. Just now we have seen that is 4 ohm. So A, C, D are the correct options over here. This is the multiple choice questions. Right. It's not a single choice, it is a multiple choice, right? So we have the A, C, D are the correct options. Okay. The EMF of the battery shown in the figure is n volt. Then find the value of n. That is what we want. N value we want. Okay. So this is 2 ohm. This is 2 ohm. And across this we have 2 volt, right? across this we have 2 volt, because 1 into 2, 2 volt. So indicates across this also 2 volt. What is the current? 1 ampere. What is the current? 1 ampere. So this 1 ampere, this 1 ampere, it is 2 ampere. So it must be then what is called as the 4 volts, right? 4 volts. So this 4, this 2 indicates at this point we have the 6 volt, right? 4 plus 2, 6 volt, and at this point we have 0 volt. Indicate this is 0 volts, right? So this is the plus minus 6 volt, indicates the current in this is 1 ampere. So this is 1 ampere, this is 2 ampere, this is we have what is called as 3 ampere. So plus minus, what is the voltage over here? 6 volt. What is the EMF then? It is 12 volts. 6 plus 6 is 12 volts. So the value of N over here is 12. So I hope this is clear. Now why I consider 6 volt over here is because, see, over here, if we consider 0, right, and if you go from this point to this point, it will be, let us consider this as x. So x minus 4 minus 2 must be equal to 0. So x must be equal to 6 volts. So this is how you have to think, right, in the circuit. So the answer for this is 12. Now the next question. A wire of resistance 18 ohm is bent to form an equilateral triangle. Okay. So one wire is given of resistance 18 ohm, which is bent in the form of equilateral triangle. So if equilateral triangle as in the angle 60 degree and lengths are same, and we want the resistance across any two vertices. Okay, so these two vertices I'll take. So 6 ohm and 6 ohm are the resistances of each branch. Why? Because it is an equilateral triangle. So this 6 plus 6 we have what is called as 12 ohm, and this 12 ohm and this 6 ohm are in parallel. So what is R equivalent over here? 6 into 12 divided by 18, so which is equal to 4 ohm. 4 ohm is the answer. So N ohm given, N is equal to then what? 4 ohm. So I hope this is clear. Now the next and the last question we have. An ideal battery sends a current of 5 ampere in a resistor. Okay, so one ideal battery is given, that indicates what? The internal resistance is 0 for this battery, which sends a current of 5 ampere. Okay, when another resistor of 10 ohm is connected, okay, so when another resistor of 10 ohm is connected in parallel to the first step, it is not connected in series, it is connected in parallel. Okay, the current through the battery increases to 6 ampere. Okay, so current through the battery increases to 6 ampere. So this current is 6 ampere. The resistance of first resistor is N ohm, the value of N. So okay, so what is R over here? R is E divided by I, that is 5. So here R is E divided by 5. So we'll calculate E firstly. Okay, so it is 10 into E divided by 5 divided by 10 plus E divided by 5 is equal to E divided by 6. That is what the total resistance is, isn't it? So we have now 10E is equal to 50 plus E is equal to E by 6. This E get cancelled. 60 is equal to 50 plus E. What is E then? 10 volts. Once we got this E, we can put it in the R value, that is 10 divided by 5, which is equal to 2 ohm. So I hope this is clear now. The N value we have is 2 ohm. Right? So I hope this is clear.